What is going on, everybody? We are moving on today. Lesson 3.5 is geometric proofs again. Last lesson, we talked about geometric proofs with segments. Today, we're going to be doing geometric proofs with angles. So some of these we've already touched on, right? These are all of the properties of congruence. This top section, these top three, we already talked about in the last lesson because they apply to all things. And these bottom parts are now just for talking about angles specifically. So we'll go through these again. Reflexive property means that something is congruent to itself, right? A is congruent to A, similar to, I always refer this back to a reflexive reflection, mirrors. If you look at yourself, your real life body is the same, congruent to your mirror body as well. Symmetric, if A is congruent to B, then B is congruent to A. Symmetric, same thing on both sides. It doesn't matter which way you flip them. It's the same thing on both sides. And transitive property, again, transitive property also can be used as substitution property, right? If A is congruent to B and B is congruent to C, then A is congruent to C. So if you think about this, if A is the same thing as B and B is the same thing as C, you can then technically substitute C in wherever you see a B. So if you were to replace this B with a C, then we end up with this over here, which is A is congruent to C. Angle addition postulate is the exact same thing as segment addition. It's just with angles, right? If you have C is on the interior of angle ABD, then the measure of angle ABC plus the measure of angle CBD will equal the measure of ABD. And if you want, I can draw a picture of that, right? If we have an angle here and it's called ABD, ABD, but if C is somewhere on the interior, this is C, and then if we have another line through here, okay, now it's saying the measure of angle ABC, which is this angle here, plus the measure of CBD, which is this angle here. If you combine those together, it will add up to the entire angle, right? So think similar to segment addition, where it's saying if you add two small pieces of a segment, it will equal the whole segment. Now we're saying if you add two small pieces of an angle, it will equal the whole angle. Okay, and definition of an angle definition of angle congruence. Again, similar to segment congruence, all this is saying is that if two angles are congruent, that means the measure of those angles are equal. Remember, congruent means that it means same size and shape, but when you're talking about a measure of an angle, you're talking just about the number. Okay, so that's what these little m's here stand for, is measure, right? So if there's no m, we're talking about congruency. If there is an m, we're talking just about the number, and that means equal. The hint there is whenever you change from a congruent sign to an equal sign, or whenever you change from an equal sign to a congruent sign, it's going to be a definition of congruence. And then the last one, definition of an angle bisector. Remember, bisect means cut in half. Bi means two, sect means cut. So bisector chops things in half, two congruent halves. Okay, also remember our definitions of angles from chapter 1. So these aren't necessarily listed on the chart that I just showed you, but they're still always definitions of angles. Okay, given that A is in the interior of angle GLD, we can conclude that the measure of angle GLA plus the measure of angle GLD is equal to measure of GLD, right? And again, we're adding two angles. So our reason why our definition, because we're adding two angles, is the angle addition postulate. Okay, this one, next one, angle 1 is the complement to angle 3. So we can conclude that angle 1 and angle 3 equal 90 degrees, right? Remember, definitions from chapter 1, this is just the definition, that's a D, sorry, definition of complementary, look at me writing in cursive, it's just as bad as my normal writing, complementary angles. That's so bad. That's okay. All right. Next one. Given the angle HAM is vertical to angle EAT. First of all, let's address this. Angle HAM is vertical to angle EAT. Come on, that's hilarious. We can conclude that angle ham is congruent to angle eat, right? Remember, the definitions of vertical angles means that they are congruent, right? And so our reason why here is the definition of vertical angles. Okay, you decide. Which one's worse? Is cursive or print? They're both pretty bad. Okay, but don't forget about their definitions from chapter 1 about angles. Okay, so making assumptions based off of definitions. Notice we have a segment and an angle, right? We're going to be talking a little bit about both today. Okay, looking at this picture, what can we conclude without any words given to us, just by the picture? Okay, notice we have congruency lines right here. We can conclude that segment AB is congruent to segment BC. But also, because these two parts of the segment are congruent to each other, which means they are equal, and since there's two of them, that means they're halves, we can also conclude that point B is a midpoint, right? The definition of a midpoint means to cut a segment in half. Okay, so this is definite. These are the two things that we can conclude just by looking at the picture without any words given to us. Over here, what can we conclude? We can't conclude really too much about angle 1 versus 2, but we can conclude, since we are given this little box here in our angle, we can conclude that angle ABC is 90 degrees. We can also say, since we know that these two angles are touching each other, they are adjacent, we can also say that angle ABD, right, that's this angle right here, use a different color, plus angle DBC, which is this angle right here, has to then equal, let's get a new color, the entire thing. That's not really much of a different color, right? The entire thing, which is angle ABC. Right, so that is something else that we can conclude, right? If we add those two smaller angles, we know that it's going to equal the big angle. And also, because we already concluded that angle ABC is 90, we could also say that whatever ABD is plus DBC has to equal 90 degrees. We could substitute. Man, look at us using all of these different properties. Okay, so remember, tips for proofs. 1, get that easy money. Always rewrite your original statement as your first statement. Always write the word given as your first reason. Always write what you are trying to prove as your final statement. Okay, use process of elimination, right? And always keep trying. When you are given geometry proofs, you will always be given a word bank to be able to fill in the blanks when you are doing these types of problems. Algebra proofs, I would be able to expect you to just do them the whole way through. Geometry proofs, there's a bunch of different ways that you could go around it. So with geometry proofs, I try to help you guys out by filling some of the blanks in already, and then giving you a word bank to be able to choose from your correct answers. Also, use the keywords that are in the proofs. A lot of times the answers will be given right in front of you, okay? So here's one that's already done. Let's take a look. Given angle 1 and angle 2 are supplementary. Well, think, what does that mean? Remember, that means that they add up to 180. Angle 2 and 3 are supplementary. That means they also add up to 180. Okay, so prove that angle 1 is congruent to angle 3, right? Remember, easy money. Rewrite your original statements as your first statement. Always write given as your first reason, and always write what you're trying to prove as your final statement. Okay, 3 easy points right there. Okay, second statement says that the measure of angle 1 plus the measure of angle 2 is 180. We know that that's true because that's the definition of supplementary angles. Supplementary means it adds up to 180, which is the same thing as measure of angle 2 plus the measure of angle 3 has to also equal 180. Okay, notice measure of angle 1 plus measure of angle 2 has to equal measure of angle 2 plus the measure of angle 3, right? All we're doing is taking these two equations, and since they both equal 180, you can replace 180 with this here, right? It's replacing. It is substitution. We could also say that that is the transitive property as well, right? Transitive property as well. A lot of times you'll see substitution and transitive property combined into one. Okay, now it says measure of angle 2 is equal to measure of angle 2, which is the reflexive property. Obviously, they're the same because they are the same thing. You could also think of this as, if this was an equation, you can also subtract angle 2 from both sides, and those would end up canceling out, which is what they have done. That is the subtraction property. And now, in our equation, what do we have left? Measure of angle 1 is equal to measure of angle 3. Right, which is what we have here in step 5. And now we have changed from the measure of angle 1 is equal to the measure of angle 3. We have changed it to angle 1 is congruent to angle 3. Remember, whenever you change from an equal sign to a congruent sign, that's the definition of congruent angles. Or opposite, whenever you change from a congruent sign to an equal sign, that's the definition of congruent angles. Okay, so we are given a proof chart. This one's super basic. Always get that easy money. Write your original statements as your first statements. So I'm not going to write the M because, again, I'm trying to save time, right? But angle 1 is equal to 45 degrees and angle 2 is equal to 45 degrees, right? And that is just given. All right, always rewrite what you're trying to prove as your final statement. Angle 2 is equal to 45 degrees. Okay, so obviously this one's a really small proof chart, but if you were to have this in like a homework or on a test or something, you already have 3 free answers out of 4. You automatically 75% on this problem. Use those free answers. Get that easy money. Okay, so now how can we actually prove that this is true? Well, if angle 1 is equal to 45 and angle 1 is also equal to angle 2, then that there, ladies and gentlemen, is the transitive property or substitution. All right, so think about it. Angle 1 is equal to 45. Angle 1 is also equal to angle 2. Since angle 1 is equal to both 45 and angle 2, you can now replace angle 1. Since it's equal to 45, you can replace it right there, right? You can substitute it, right? So transitive property or substitution. That is how we find out that it is also equal to 45 degrees. Okay, this one's a little bit longer. I apologize if my picture of my face is blocking this example. Just listen instead of watching, or do both, but listen so you know what I'm writing even if you can't see it. Always notice your word bank. You are given 3 statements and 3 reasons. Notice, though, there's 1, 2, 3, 4 lines. But we all know that you can get this first statement and first reason all by yourself because it's part of that easy money. You can just rewrite what is already given to us, right? Angle A equals 90 degrees, and angle A is congruent to angle Z. That is always given. Okay, and it wants to prove that angle Z is the right angle. Well, whatever we try to prove, that's another easy money answer. Always put that in as your last statement. Angle Z is right angle. Again, I'm just trying to not write as much because I'm terrible at it. Notice, right, we already get to use process of elimination. We can cross that one out. We're never going to use it again. Okay, so now think. What is a logical way to move from what we've written here to go to here? Let's look at our answers. Okay, measure of angle Z is equal to measure of angle A. Well, we just got done saying that angle A was congruent to angle Z. Now we're just saying that angle A is equal to angle Z. I feel like that would be a logical thing to write down next. Then we can write that angle A is equal to angle Z. Right? And now think, what is our reason? Well, we have changed from a congruent sign to an equal sign, so that means we are going to use definition of congruency there. Definition of congruency. Okay, again, just abbreviating, trying to make things easier. Okay, now we only have one answer left, so let's put angle Z is equal to 90 degrees. Angle Z is equal to 90 degrees. We know that that is true. How do we know that that's true? Well, again, if angle A is equal to 90, and if angle A is equal to angle Z, that's, again, the transitive property. So if A equals 90, but A also equals Z, right? These are both the same thing. You can replace, you can substitute, right? So this is the transitive property or substitution. They are the same. Which means we only have one answer left. This last one has to be definition of a right angle. And also, it's pretty self-explanatory. If angle Z is equal to 90 degrees, then we can conclude angle Z is a right angle because the definition of a right angle is being 90 degrees. Okay, so these are difficult, but they are also very common sense and logical. Okay, let's do another example. Given ray RV bisects, remember bisects means to cut in half, angle SRT, and we also know that angle 3 is congruent to angle 1, right? We are given 3 answers. We have 3 statements that we need to write. Well, awesome. One of them is always going to be given. That one's super nice. Okay, now how do we get from angle 1 is congruent to angle 2? Well, we know that segment RV, which is right here, bisects, which means to cut in half, angle SRT, which is this here, right? This angle right here. Well, if it bisects, the definition of a bisector means that it cuts in half, which means we can conclude that angle 1 is congruent to angle 2, which is what we have already done. And I already said the answer. It's definition. Oh, here, look at me. I don't even have to write the whole word. I can just write the letter. Definition of a bisector is A, right? Definition of a bisector given goes there, right? Which means that the last one, I don't even have to look, is B, but let's do it so that way I can explain why. Okay, so if angle 1 is congruent to angle 2, how can we conclude that angle 3 is congruent to angle 2? Well, in our given statement, we found out that angle 3 was congruent to angle 1, and we found out that angle 1 was congruent to angle 2, so therefore you can substitute and then say that angle 3 is congruent to angle 2, right? Substitution, remember, also it could be technically the transitive property as well. Cool, let's do another one. Okay, again, always write the word given as our first reason. Okay, so what is actually given to us? Ray, AH, is the bisector. Bisector means to cut in half. Bisector of GAI, right? And we are also told that angle 1 is congruent to angle 3. So angle 1 is congruent to angle 3, right? That is given to us. Now prove that angle 2 is congruent to 3. Well, since it's bisector, we can now conclude also that angle 1 is congruent to angle 2. Notice, key words, bisector. Guess what? Number 2 is the definition of a bisector. Look for your key words. And if 1 is congruent to 3 and 1 is also congruent to 2, then therefore we can conclude that 2 is equal to 3, which means that this is either the transitive property or the substitution property. Same thing. Beautiful. Okay, that's all I have. Okay, just a few examples. Please make sure you bring any questions to class. That's it. Go team. Go Mustangs.